So let's go ahead and grade the test for Chapter 2. The first question, it says, define the following terms. And so the first term is a mixture, which should be something about a combination of two or more pure substances. A heterogeneous mixture is a mixture whose composition is different in different parts. It's not spread evenly throughout, but there's differences in different places. C, an element is something that cannot be chemically broken down into smaller substances. Let's see, a molecule is two or more atoms that are linked together, and an isotope is an atom of an element with differing numbers of neutrons. So they have the same number of protons because they're within the element, differing numbers of neutrons. Number 2, classify the following as an element, compound, heterogeneous mixture, or homogeneous mixture. A, an egg would definitely be a heterogeneous mixture. B, a sample of lithium chloride, which can be broken down into lithium and chloride. Well, obviously that is a compound because it can be broken down. C, the air you breathe, that is a homogeneous mixture, and any of you that took physical science are painfully aware of that. D, a wire of copper that cannot be broken down into simpler substances, so that would be an element. So A was a heterogeneous mixture, B was a compound, C was a homogeneous mixture, and D was an element. Number 3. In an experiment, a student burns 115.6 grams of paper. He collects all the products, finding that it's produced 10.2 grams of ash, I can do this. Reading them is going to be hard. Number 3, in an experiment, a student burns 115.6 grams of paper. He collects all the products, finding that it produced that much ash, that much carbon dioxide, and that much water. Sorry, I have trouble getting it all out right, so please forgive me. How many grams of oxygen were consumed in the burning process? Okay, well, we know that we started out with 115.6 grams of paper. And he collects all the products. So let's look at the product. We have 10.2 grams of ash. We have 98.1 grams of carbon dioxide. And we have 45.6 grams of water. So if you add all of those up, you get 153.9 grams of stuff. Now, how many grams of oxygen? Well, we know we had some oxygen in there, don't we? Because we ended up with some extra. So if we go 153.9 grams minus the amount of paper, that's what we're burning, right? Yep, that we started with, that should give us the amount of oxygen, which is 38.3 grams of oxygen. That's how you'd figure it out. So you'd add up everything that you got back, and that would be this plus the oxygen. And so you would just subtract the paper from the total, and that what's left would be the amount of oxygen that was added to it in the process of burning. 38.3. Okay, number 4. True or false? Because carbon monoxide is made from the elements oxygen and carbon, it must have some of the same properties as oxygen and carbon. That is false, because remember, when you have a new molecule, you have new characteristic properties. I went over that in great detail in class. So it's got unique characteristics. So the answer is false. Okay. Number 5, you didn't have to say all the rest of that, did you? No. Just had to say true or false. Yay. Number 5, a 101.96 gram sample of solid is broken down into that much grams of aluminum and an unknown amount of oxygen. If a chemist wants to make that many grams of that solid without any leftovers, how much aluminum and oxygen should she react together? Okay, so first off, you have a sample And we have to know how much of each we have, because otherwise, if you don't know how much of each you have, then you can't figure out how much you're going to need. Excuse me. So we have 101.96 gram sample, and we know that there is 53.96 grams of aluminum. So we're going to go minus 53.96 grams of aluminum. This is sample. And so that's going to end up giving us 48 grams of our oxygen. Oxygen. I'm going to go ahead and put O2 here. You could write out oxygen. Okay. So there's our known total sample. That's the amount we were told of aluminum. So when you get the difference, that would be your unknown amount of oxygen. And we are told that the chemist wants to make 1,937 grams. And here we know how to make 101.96 grams. And so if you divide those two, you get 18.997 in your calculator. Grams is going to cancel. But you have 5 significant figures here, but 4 here. So you're going to have 4 here. And so when you do that, this is going to roll this up, this is going to roll this up. You're going to end up with 19.00. Okay? 19.00. And then what you're going to do is you're going to take the amount of aluminum, which is 53.96 grams, and multiply it by 19.00. And you're going to take your 48.00 grams of oxygen, this is your aluminum, and you multiply that by 19.00 grams. Okay, and so when you do this, you have 4 significant figures, so it's going to be 1,025 grams of aluminum. And this one is going to be 912.0 grams of oxygen. So that's how you would figure that out. What we have there, I just want to look. That's number 5. Yeah, you have 3 separate steps going on there. You have one to find this, you have one step to find the ratio, and then you have one step to find the actual amounts there. And let's see, each problem, well, the way he's got it figured is that this is worth 3 separate points, and each point is worth 4 points. So this problem is worth 12 points, as in real points, like if you're going from 100 and subtracting. Finding this part was worth 4 points. Finding this part was worth 4 points. And finding this part was worth 4 points. So if you need some help on that, ask me in class. Okay? And if you really had a problem with it, do it over again. Go back and study these and do it over again. Okay, number 6. A chemist reacts 24 grams of carbon and 24 grams of oxygen to get 42 grams of a gas along with some leftover carbon. In another experiment, she reacts 30 grams of carbon with 40 grams of oxygen to get 70 grams of a gas. Are the 2 gases the same? Okay, so let's look at that. The first one, we have 42 grams of gas. I'm going to put gas here. And we have 24 grams of oxygen. So I'm going to subtract from that 24 grams of oxygen. And so that's going to give us 18 grams of carbon that's used up there. Okay, on the next one, we have 70 grams of gas. And we have, let's see, 40 grams of oxygen. So it's 30 grams of carbon, right? So if you take the 24, in other words, you take the ratio of oxygen to carbon in the first one, And then you take the ratio of oxygen. This is oxygen. This is carbon. This is oxygen. This is carbon. And the second one, so you go 24 divided by 18, that gives you 1.33. And 40 divided by 30 also gives you 1.33. So the question was, are the two gases the same? The answer is yes, because they both give you this same ratio. And so they have the same ratio of oxygen to carbon, and therefore they are the same gas, just in differing amounts. You were supposed to write down the 4 propositions of Dalton's atomic theory. Hopefully everybody did that. You said something about that atoms make up everything and that they're indivisible and indestructible. And then the second one was all atoms of a given element are identical in their properties. The third one was they combine to form compounds, and then they rearrange the atoms. Did you write them up corrected?
Yeah, no, I mean, I did them. I just had another question.
Oh, what's your question, sweetie?
My question was, okay, so I memorized them like the way that they were supposed to like be memorized and how they did in the book. But it's so much easier because I know like it as like another way. Like I just say it like in my own words. Is it? Can I do?
No, your own words is fine.
Okay.
Absolutely, you're always okay with your own words as far as I'm concerned.
Okay.
Except for with Scripture. Then we should try to stick to Scripture. But otherwise, your own words works. You know, so that's great. That's fine. Okay. So something like that. That's what you were supposed to have. Something like that. Number 8. Which of the propositions were in error? Or excuse me, were not in error. There were no errors. That would be 3 and 4. Number 9. Number 9. A chemist is making a compound that is composed of 1 platinum atom and 1 oxygen atom. To make 21 grams of it, she must react 19.5 grams of platinum with 1.6 grams of oxygen. She then wants to make another compound which is composed of 1 platinum atom and 3 oxygen atoms. How many grams of oxygen must she react with 19.5 grams of platinum to make this gas? So all you'd have to do is, the platinum is fixed in both cases, right? Which we have that at 19.5 grams. Okay, but this time we're going to do 3 times the oxygen. So you're just going to take the oxygen from the previous example and you're going to multiply it by 3, so that's going to give you 4.8 grams of oxygen. So that's all we were supposed to do there, is know that that was fixed and take the oxygen that was used in the other one and then multiply it by 3. I'm not even going to read it. You were supposed to, how many grams of oxygen must she react? You were supposed to react 4.8 grams of oxygen. Does anybody need to see that one?
I just have a question.
Yes, ma'am.
So I understand how you got 4.8, but 4.8 divided by 3.2 is 1.5, and that's not a small whole number. But I still fixed the amount of platinum, 9.5 and 3.2, and then 9.5 and 4.8. But that's 1 point. That's not a small whole number.
Okay, I see what you're saying. Hang on.
So I thought it was 6.4.
Okay, to make a compound that's composed of 1 platinum atom, 1 oxygen atom. To make 21 grams of it, she must react 19.5 grams of platinum and 1.6 grams of oxygen. She then wants to make another compound which is composed of 1 platinum and 3 oxygens. It's 1.6. Okay. And what did you say?
I said 6.4 because 6.4 divided by 3.2 is 2, rather than 1.5.
Divided by 3.2. Where did you get the 3.2?
Because here, it says that.
Oh, you did the 21.1 divided by 19.5?
Well, no, I said 19, because when I fix the amount, I'm fixing the amount of platinum. So I have 19.5 grams of platinum for everything. So I have 19.5 and then 1.6. And then I'm saying for two, if I had 2 oxygen atoms, I would have 19.5 and 3.2. And then, but they said if
You're talking about the ratio between the platinum and the oxygen.
no, I'm saying like if I have 19.5, if I fix it, then I have 1.6 grams of oxygen. And if I have 2 oxygen atoms, I still have 19.5 because I fixed it. But then I have 3.2 grams of oxygen, and 3.2 divided by 1.6 is 2. So that's a small whole number. So, but if I keep fixing it, and now I have 3 oxygen atoms, I understand how you get 4.8, but if I divide 4.8 divided by 3.2 is 1.5.
Why would we divide it by 3.2?
Because I thought
No.
you still fixed it.
No, you would divide the 4.8 by the 1.6, not the
That's the only one that
3.2.
works?
Yes.
Okay, because I didn't understand.
Yes, 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 yes.
So it has to be the original.
Yeah, and I see what you're asking, but you have to do it from the original one.
Okay.
And the reason is because I know you guys haven't learned it enough yet, but you don't know that there's something that can be formed with platinum and 2 oxygens. You know, so that may be why.
Okay.
Okay? Okay, I do see what you're saying. It took me that long. I'm sorry. Oh, we need lunch. Okay. All right, number 10. Which of the following drawings is the most accurate model for the atom? You tell me. C, right. Number 11. What do we call the place where the protons and neutrons are found? Nucleus. Number 12. Yes, it's A. Did you not get that one?
No.
Okay. Number 13.
I got it. It's just never mind.
Which of the subatomic particles you learned are positive? Protons. And chemists are studying 2 isotopes of chlorine. One is heavier than the other. Does the heavier one have more protons or neutrons? Neutrons. Okay, each answer is worth 4 points, including each of the vocabulary words are worth 4 points. Okay? Always subtract what you missed, never add up. That's important. Okay, let's put that away.